do question 2 now. You have a transfer function and you need to determine y of t, which is the output, and then determine what is y as t approaching infinity for two different inputs. One is step input of magnitude m and another one is sine t. So what we are saying when we say that we have a step input of magnitude m, this is basically we are saying that our u of t is equals to m. Okay, for us to be able to use this, we need to transform it to S domain. We need to use a Laplace transform. Okay, so when you Laplace transform a function u of t, you will get u of s, and m is a magnitude, which is a constant, so you will have m over s. So this is the one that you're going to use later. Meanwhile, for a sine t, what we are saying here, our input is u of t equals to sine t. So you use a Laplace transform to transform sine t. Okay. Now this is where table 3.1 Laplace transform table is useful to you. You need to find an item of sine t. Okay, I have it here with me. So let's scroll down. So we have sine t here. And sine t is given as, when you Laplace transform it, it should be equals to omega over s squared plus omega squared. So in this case, since I have sine t, my omega is 1. Right? So my u of s is basically 1 over s squared plus 1 squared. Okay? Alright, now let's do A first. Okay, for A, we know that this is always the case. Output y equals to transfer function j multiplied by input u. Okay, so we are going to just expand the equation. So we have 10 multiply with 10 over 5s plus 1, 3s plus 1, and we multiply with m over s. Okay, so we have y of s. So now what we need to do is we need to find the y of t based on this equation. So first of all, we need to do a partial fraction. Why we need to do partial fraction? Because we need to determine the numerator for each of the roots that we have here. As you can see, we have 3 roots, that, and that. Okay, so by partial fraction, we have is 10 over 5s plus 1, 3s plus 1 s, that is m, equals to, okay, since our roots, if you see our roots here, each of these are actually what we call as real and distinct root. For this one, we have s equals to minus 1 over 5. This one, s equals to minus 1 over 3. And here, s equals to 0. Okay, so we don't have any complex conjugate. So what we can do is we can actually separate each of the roots with different numerator. B over 3s plus 1 plus c over s. Okay, so for me, I would like to solve it this way because this is real and distinct root. I'm going to multiply the denominator for a, which is 5s plus 1, with the overall transfer with the overall y of s. Yeah, in this case it is 10. Yeah, by the way, you have m here because you are expanding the whole equation here. You are expanding this equation. Okay. So basically, this m can be cancelled with that m. So what I have is 5s plus 1, this is 5, okay, 3s plus 1 multiplied by s. And then we are going to evaluate that at the root, which is minus 1 over 5. Okay, so you can see this part can cancel with that part. So what's left for us is 10 over 3 multiplied by minus 1 over 5 plus 1 multiplied by minus 1 over 5. Okay, so this is actually equals to, okay, let me just continue here, 10 over minus 3 over 5 plus 1, it becomes 2 over 5, right? 2 over 5 multiply with minus 1 over 5, and this is equals to 10 over minus 2 over 25, and this is actually equals to minus 10 multiplied by 25 over 2, which is minus 1 to 5. Okay, so that is our A. Okay, we are going to do the same method for B. So for B just now, the roots is 3s plus 1. So we are going to do for B. B is equals to 3s plus 1. We multiply with 10, 5s plus 1, 3s plus 1, multiply with s, and we are going to evaluate it at s equals to minus 1 over 3. So we can see this and that can be cancelled, and what we have is 10 over 5 multiplied by minus 1 over 3 plus 1, and this multiplied by minus 1 over 3. So what I have now is 10 over minus 5 over 3 plus 1 multiplied by minus 1 over 3. And when you solve this, you would get, let me see, 10 over minus 2 over 3 multiplied by minus 1 over 3, correct? So this is basically 10 multiplied with 9 over 2, so it is basically 45, right? Let me see, am I right? Okay, let's continue with the last part, which is C over S. Yeah, this part. Okay, so for C, okay, what we have here, this is for B just now. So for C, we know that it is S multiplied with 10 over 5s plus 1 multiply with 3s plus 1 multiply with s, and we are going to evaluate that at s equals to 0. So we see that s can cancel with s, and this leaves us with 10 over 1. So this is basically 10. Yeah, so this is actually 10. Okay, so next we are going to put every numerator that we have calculated into the equation. So now we have y of s equals to just now we have minus 1 to 5. Okay, so it should be minus 1 to 5 over 5s plus 1 plus 45, this is our b, right? 3s plus 1, and then plus 10 over s. Okay, next thing we are going to do an inverse Laplace transform. Okay, this is almost final actually. So what we are going to do, we are inversing all terms that we have so that we can have our y of t. Okay, so in this case, minus 1 to 5 over 5s plus 1 plus inverse Laplace 45 over 3s plus 1 plus the inverse all terms. Okay, so this part is easy, it's always y of t. Okay, but the other one, okay, this is also easy actually, but you can refer to the table to be sure. So when you refer to the table up here, okay, remember what we have is certain, what we have just now, we have 1 to 5 over 5s plus 1. So when we look here, is there anything that's almost similar to that? Yes, what we have is item B, this one. It's just that we need to actually rearrange our terms. So when we arrange this term, it becomes 1 to 5, we divide by 5 because we want to have s, okay, over 5, right? So what we have, 1 to 5 over 5 is 25, okay, over s plus, this is s, sorry, this is 5, s plus 1 over 5, okay? So this term, when you inverse Laplace it, it will give you 25e to the minus 1 over 5t. Okay, so we are going to bring this down and put it in our Laplace transform. So what we have here is 25e minus t over 5. Okay, we have minus, yeah, minus, right? And then same thing for this part. Okay, what we do is we actually rearrange. So when we rearrange, 45 divide by 3, this is 3 divided by 3 will give you s plus 1 over 3. Yeah, so basically this will give you 15 over s plus 1 over 3. So your e or your inverse Laplace transform is basically 15 e minus t over 3. 10 over s is simple, it is basically just a constant. Okay, so this is your y of t. Okay, next thing, what you want is you want to find limit of t goes to infinity for your y of t. Okay, so there are two ways to do it, but as usual I like to do using the S domain, which is the final value theorem or the initial value theorem. So as t goes to infinity, it is actually equals to s goes to 0, s multiplied by y of s. Yeah, so in this case what I have is limit s goes to 0, s multiplied by 10m over 5s plus 1, 3s plus 1 s. Okay, so I can cancel that, and this is equals to 0. This also equals to 0. So this, it is equals to 10m. So this is the value for my y as t approaching infinity. Okay, all right, let's do part B.